Welcome back to the course Modeling Combustion with Answers Fluent offered by Edal Systems. So in today's class we will discuss about post-processing of results. So till now we have discussed about how we can solve a combustion problem using Answers Fluent. So in this class we will understand how we can post-process the results which we have generated in Answers Fluent. So here we have some of the post-processing options which are available in Answers Fluent to visualize our results. So we have our case files and data files. So when we are importing the data files again, we can generate these results. We can create various alphanumeric reports and various contours, XY plots, everything. So these all points I have listed here and we will discuss each of them step by step. So the first point which we'll be discussing is manipulating mesh in viewer. So we can display our mesh in various styles. So this is the dialog box for displaying the mesh. So here we can see there are various options available, that is displaying mesh, outline display, mesh edge display, mesh face display, node display. So using these options we can display our mesh and we can play with it the way we want. Suppose we are clicking with the edges, then we can only see the edges of our domain. If we click on the outline, again we will see outline. But if we are switching on the mesh face display, then we can see it with the mesh. So here I have added one figure. So here we can see when we are using the multiple options and just finalizing one, then we can see our mesh and Answers Fluent GUI in such a way. So the next thing is adding lights. So in adding lights option, you can use some extra lights to understand and view the domain with more clarity. It enhances the display with shading. So we can change how the model is displayed or how the mesh is displayed, and then we can offer different lights to it. We can change its shading and etc. So headlight is one of the option which one can use. So in this option, it provides constant lighting effect from a light source directly in front of the model in the direction of the view. So these are the dialog boxes which we can use to alter the lighting effects in Answers Fluent. So the next part is creating isosurfaces. So isosurfaces are very useful when we are doing post processing, because to display our results in a 3D model, you will need a surface on which the data can be displayed. So we can create different isosurfaces using this dialog boxes. We can create symmetry planes, we can create clips, etc. Then after creating these surfaces, we can create contours on these surfaces, these isosurfaces and isoclips. Also we can see various other variables, surface integrals, volume integrals on these surfaces. So we can visualize results at those particular surfaces which we are not able to see in a full model. So we can dissect our model into different parts using isosurfaces, line, points, stakes, etc. So isosurface is one of the part. Then we have is generating contours. So once you have generated your surfaces, that is isosurfaces, or you have to visualize a result at your inlet, outlet, and see how the variation is there along the axis. So you can use contours. So contours helps to identify the parameters with their magnitude in a particular region using colors. So these are some of the features which we can use, and this is the dialog box which we can use for generating our contours. That is, we can draw filled contours, or otherwise we can just use lines. Then we can display our color map labels to the scale which we have, in which we will get our minimum and maximum range. We can change the position of that color map, we can change the values, we can change the colors which it shows, then specifying the range of magnitudes displayed. So here in the minimum and maximum range which it shows, we can alter that as well. Then we can include the mesh in our contour plots. Then we can even save this contour plots how we need in different formats. So that also we will see in further slides. So here I have added some of the examples that how the contours are generated. So the first figure, it just shows a filled contour of temperature at the surface. Then the next contour is a filled contour, but it has cut it out between rectangles. So that is an isoclip surface. So this contour is plotted at an isoclip surface. Then in next contour, we can see that the scale, the color map has changed from vertical to horizontal at the bottom. So these all changes we can make, and we can play with the contours option. The next option is generating velocity vectors. So vectors helps us to understand the direction and magnitude of the velocity of the flow in a specified region with help of arrows and lines. It provides an excellent visualization of the flow around the model, depicting details of the wake structure. Velocity vectors are very useful when we are having a problem which involves recirculation zones, which we have in our combustion problems. So we can see how the flow is varying and in which direction the wakes are forming, etc. So even here we have several options like displaying relative velocity vectors, scaling and skipping, displaying vector components, specifying range of magnitudes displayed, changing the scalar field used for coloring the vectors, then creating custom vectors. So this is the dialog box for velocity vectors. So here we can play with the scale and skip. Then we can change the style from 2D arrow, 3D arrow to different other parameters. Here also we can change the color map or position. Also we can change the magnitudes of the range which is displayed. Here also I have added some three figures for understanding how velocity vectors works. So this is the velocity vector at the surface. So we can see arrows are moving in downward direction. Then we have velocity vectors intersecting the surface. Here in the first figure, we can see that just vectors are displayed. So even we can put a surface in between and we can see how the variation is happening with the intersecting surface. And next we have velocity vectors after mirroring. So we can also mirror our images. We can do it for half model, we can do it for full model. So this is the display after displaying the velocity vectors for the full model. Then we have is creating animation. So using Ansys Fluent, we can animate the solution and also a scene. So there are two types of animation we can use, that is keyframe animation and scene animation. So once you have displayed a vector or a contour, you just have to add one key and then you can add multiple keys, say 100. So if you add 100 keys, so Fluent will generate 100 steps in between from 1 to 100 with the static results which it has generated in the solution. So after finishing a keyframe that is capturing this part, we can go into playback and we can play this animation so we can see how the results are generated or how the flow is moving. After viewing the animation, we can select right and then we can save this animation as a video file in our system. One more thing when we are dealing with this animation is one should have a good graphic design workstation with it to see the animations, because these animations may take a longer time and they won't be clear. So a good workstation with a good graphic display configurations can give very smooth and good quality animations. So these two options one can use when they are creating an animation. Then the next option is displaying path lines. So path lines are the lines traveled by the neutrally buoyant particles in equilibrium with the fluid motion. Path lines are an excellent tool for visualization of complex 3D flows. So even in path line, there are various options that we can include a mesh in the path line display. Then we can control the path line style, controlling path line colors, then thinning path lines, coarsening path lines, and reversing the path line. This is the dialog box. So same like vectors, we can do this, but here the path lines we can do for other variables as well. The vectors we can do just for velocity, but for path lines we can choose any of the variable, that is pressure, density, temperature, anything, and we can do generate this path line. So I'll show you how the path lines are displayed. So the first path line diagram is with a straight lines, and then the next we can see that spheres are displayed. So we can change the style from line to spheres. Then we can also edit some of it by doing surface ID. So we can color our sphere path lines using a surface ID as well. So we can display all our results, the contours, vectors and path lines. So to visualize our solution using isosurfaces and isoclips. So next is overlaying in scene description. So the overlaying capability provided in the scene description dialog box allow you to display multiple results on a single plot. Now suppose there is a case where I want to see vectors as well as my path lines in one single plot. So I can use this option of overlaying. This is the dialog box for the overlaying option. I'll show how it can be viewed. So using this dialog box, we can alter some of the features, and here we can see overlay of velocity vectors and path line display. So both of them are merged together in a single display and we can visualize our results more clearly. Then the next option is creating exploded views. So the scene description dialog box stores each display that you request and allow you to manipulate the displayed items individually. This capability can be used to generate exploded views in which results are translated or rotated out of the physical domain for enhanced display. The exploded view allows you to see the contours and vectors at distinct place in the final scene. So this is the dialog box where we can alter some of the features and then we can create an exploded view. Here is an example of how we can create an exploded view. So this is exploded scene display of temperature and velocity. So here we have temperature as well as velocity in one single frame. We can generate such kind of exploded view in ANSYS Fluent. The next option is animating the display of results in successive stream-wise planes. So you may want to march through the flow domain displaying a particular variable on successive slices of the domain. While this task could be accomplished manually, plotting each plane in turn or using the scene description and animate dialog box. So not to waste much of the time and doing the hard work, what we can do is we can use the sweep surface dialog box to facilitate this process. So this is a dialog box for the sweep surface description where we can create the display of results in successive streamwise planes. So next is generating XY plots. So plots are always necessary when we are about to show any profiles or something. We can create XY plots which can be used to display quantitative results of our CFD simulation. So this is the dialog box where we can plot anything in any direction for any surface, any variable. Here also after generating a plot we can write to our system in a CSV file, an Excel file or anything in which format we want to generate the report. So we can create different lines on which we want to see the variation of any particular variable. So we can create the lines. So line dialog box is also shown here. So we'll see how an XY plot looks in ANSYS Fluent. So after generating a plot, we can see this is how it will show in ANSYS Fluent. So this plot is generated. Next thing is we can also create an annotation for the plot we just generated. So you can annotate the display with the text of your choice. So we can change this annotation based on our choice and we can save this file directly to our system. Then we have is saving hard copy files, which I just discussed. So you can save hard copy files of the graphic displays in many different formats. These formats vary from a plot file to an image file, also to a video file. So these are certain formats in which we can save our hard copy files, and this is a particular dialog box to save an image. So when we have generated a contour and we want to save this contour to our system, we can use the save picture option and then we can change some of the factors, that resolution, color type, file type, and then we can save this image directly to our system. The next part is generating volume integral and surface integral reports. So reports of volume integral can be used to determine the volume of a particular fluid region, the sum of the quantities or the maximum and minimum values of particular variables. So this can be generated for volume integral reports as well as for surface integral reports. So if you want to see how much fluid volume has been passed from an inlet or how much volume of fluid has been passed from a certain wall, we can use this volume integral report option and we can generate reports as well. Same can we do with the surface integral reports where we want to calculate a particular variable at any surface and then we can save this value directly to our system. These two are the dialog boxes for generating volume integral and surface integral reports. So summary for today's class is that we have seen various post-processing features of ANSYS Fluent. First, we have seen mesh display where we can manipulate it in different ways. Then we have seen different lighting effects can be added to enhance the light and shade of the domain for better visualization. After that, we have seen how we can create ISO surfaces and ISO clips for better visualization of results. Then we have seen contours, which helps to identify the parameters with their magnitude in a particular region using colors. Also then we have seen some velocity vectors which are an excellent visualization of flow around the module depicting details of the wake structure. Then we have seen animations can also be created using keyframe animation or scene animation. After that, we have seen how we can generate path lines, which are an excellent tool for visualization of complex 3D flows. After that, we have seen how we can develop multiple results in a single plot using overlay option. After that, we have seen we can also create exploded views, which will allow us to see the contours and vectors as distinct displays in the final scene. Then we have seen how we can use surface, which will help to march through the flow domain displaying a particular variable on successive slices of the domain. After that, we have seen how we can XY plotting, which can be used to display quantitative results of our CFD simulation. Then after that, we have seen that how we can annotate the text which we are using for generating our XY plot, so we can vary even that text. Then we have seen we can save hard copy files of our graphic displays in many different formats. We have seen all these formats. Then we have seen that we can generate volume integral as well as surface integral reports for our simulation result. Even surface integrals is best option where we can calculate mass weighted average quantities for our results. This was the entire summary for post processing of results for any simulation. We can use this for 2D and we can use this for 3D as well. So the references for today's class are present here, and we have finished with this course as well. Thank you.